triangle. If I gave you this triangle, what type of triangle is it going to be? And I want you to find out that angle A. I'm telling you that's 3 and that's 5. I'm looking for angle A. Is there any point in me using Pythagoras' theorem? No. Because what will Pythagoras' theorem give me? The other side. So I have to use Sohcahtoa. Anytime you go to use Sohcahtoa, you have to name the sides. So I'm looking for A. Relative to A, what side is that one over there? And what is this side up here? So because it's opposite and hypotenuse, I must use what ratio? No. Sine. Who does sin? Religion. Right? We'll do sine here. Sounds nice. So because it's opposite and hypotenuse, so I'll write down the sine is equal to the opposite divided by the hypotenuse. The sine of which angle? A is equal to the opposite divided by the hypotenuse. The sine of the angle A, that is a fraction. I put it into a decimal, 0.6. To get A then, A is the sine inverse of 0.6. So you go to your calculator, you hit shift button, sine 0.6, and it will give you 36.87 degrees. Could you give me that in degrees and minutes if I asked you first? 36 degrees, 52 minutes. Right? So there is one use of Sohcahtoa. If I give you two sides, what can you tell me? You can tell me the angle. Now, if that's 36.87 degrees, that's 90 degrees. Would you now be able to tell me that angle? Why? They all add up to 108. Is that good? Huh? Are you now excited? You sure look it. Right angled triangle. 4, 7, and they want me to work out here angle B. Now you're going to hear this said hundreds of times. The first thing you do when you have to solve a right angle triangle is you write down Sohcahtoa. Because if you're not going to use Pythagoras' theorem, it's Sohcahtoa. To use Sohcahtoa, you have to name the sides. So relative to that angle, what side is that? And what side is that? Opposite and adjacent. I must use the tan ratio. I will now say that the tan is equal to the opposite over the adjacent. The tan of which angle B is equal to the opposite, 4 over, fraction has to be put into a decimal. The tan of the angle B is equal to 0.5714. 4 decimal places always for an angle, unless it has divided in evenly before that. Then how do you get the angle B? It's the tan inverse of 0.5714, which is 0.74 degrees. And put that into degrees and minutes. It's 29 degrees, 44 minutes. I'm not interested in what's after the degrees and the minutes. I'm then into a fraction of a minute, which I don't need. Is that all right? I'll do one more of those for you. This is the angle C 11, 13. Once I'm looking for an angle, what's the first thing I will write down? Sohcahtoa. And when I've written down Sohcahtoa, I must then decide, do I use sine, cos, or tan? How do I decide that? Name the sides. So relative to this angle, that one would have been what? The opposite. What's this one here? Hypotenuse. Why is it the hypotenuse? And the other one is the? Adjacent and hypotenuse means I must use what? Cosine. The cosine of an angle is equal to the adjacent over the hypotenuse. The cosine of my angle C is equal to the adjacent over the hypotenuse. The cosine C must be put into a decimal with 4 decimal places. 8, 4. So C then is equal to the cosine inverse of 0.8461. The cosine of C is 32.21 degrees, which is 33 degrees and 12 minutes. Now I need your attention back here for a moment. What has happened in this? What have you been given? In each of these triangles, yes? 2 sides. And from the 2 sides, what did you find? An angle. Now please focus in here. I now know that angle to be what? 33 degrees and 12 minutes. Or 33.21 degrees. That's 90. Would you be able to get that one? So now you know the 3 angles. Yeah? You only know 2 sides. Would you be able to find the 3rd side? How? And you know everything that there is to know about that triangle then.